One final thing with respect to the calculation of slope functions. When we get to SPSS, what you will notice is that it gives standardized regression coefficients. So a standardized slope function and a standardized y-intercept. And we'll see. And all that is the calculation of the slope function and the y-intercept using these z-scores. So over here, I'm back to my regression. So z of x and z of y. We know that's equal to 30 minus the mean divided by the standard deviation. Across. And we'll see the mean is 0 and the standard deviation is 1. So done a good job. Okay. So the R for the z-scores is equal to the correlation. I'll use Excel. Correlation of x and with y. And it replicates our correlation coefficient that we had when we used the actual values. The slope, B, is equal, beta it's actually called, because it's based on the z-scores, is a correlation times by the standard deviation of y with the standard deviation of x. The correlation is 0.639. The standard deviation for y is 1, and the standard deviation of x is 1. So I'll go through it, but it's simply the correlation times by the standard deviation of y divided by the standard deviation of x. And that should be the correlation coefficient. So for simple regression, your slope is the correlation coefficient. Then the y-intercept will be equal to 0. So y-intercept is equal to the mean of y minus the b value slope function times by the mean of x. And it is 0. So you will see this on SPSS when we see it later. And if I look at it as a scatter plot, and if I add the line, you can see how it goes through 0, and you can't readily see it, but the correlation is the slope function is the correlation.